Hello there, welcome to this video. This is 9-6 and we are going to review basic integration skills. We've done it. We're at the end of Calc AB and these last two lessons are just mainly going to focus on doing everything we can to integrate different types of integration problems. And my calc professor at college said just try everything, eventually throw the kitchen sink at it. Just see what you can do to effectively integrate, and that's what we're going to be doing. Now, there are a long list of integration formulas that you can use on page 211. So if you want to go ahead and study those are things that you might want to utilize on flashcards and just kind of memorizing. Memorization is not going to be enough. Differentiation, you can go ahead and take a derivative and follow kind of like the the cookie cutter process step by step, and that'll work. Integration is more difficult because some problems, they look alike, right, and they're disguised, and you have to be able to kind of recognize like what piece do you actually have, and what's legal and what's not legal. Okay. So this lesson, I'm going to split it up. The first video, I'm going to go ahead and I call this the Doppelganger video. We're going to look at some lookalikes and kind of see, okay, what are the little nuances between them? How can we integrate them? Okay, so just some general strategies that we're going to go ahead and do is first, memorization of the general formulas. Okay, that's very, very important. Like, what is the integral of sine? What's the integral of cosine? What's the integral of 1 over x? Okay, things like these should just be able to come to you very easily, and you should have good recall. Second, you need to go ahead and kind of recognize what formula can I use for this process? Like what is the type of problem I have? What's the setup? And what's my general approach going to be? Third, you have to be able to use some algebraic skills and techniques to be able to put problems in forms that you can go ahead and integrate. Okay, so algebraic skills are helpful. And then lastly, number 4, very, very important, just lots and lots of practice. Over the next couple of months, I plan on doing integration daily with you and just kind of practicing these skills and hopefully kind of, working on it. Okay, example 1, let's go ahead and look at my doppelgangers here. Okay, so here we want to go ahead and integrate these 4 lookalike problems. So just notice they look similar, however, there are very, very completely different types of integration formulas. And actually, I'm gonna mess with you. I want to go ahead and I want to start out with D, because D should just kind of be your general approach. I look and I see an integral where I have a power in the denominator. So 1 plus x quantity squared dx, right? Now, if I want, I can go ahead and I can take this binomial in the denominator and I can go ahead and I can bring it up. This is 1 plus x to the power of -2 dx, and then I can just go ahead and integrate. I don't have a hook because the denominator of the inside, right, is the derivative of the inside is just 1, so I can just use simple power rule. So 1 plus x, okay, so this power, I'm going to add 1, this gives me -1. I'll divide by -1 and we get plus c. So here's your answer, right? Negative, and if you want, you can go ahead and drop this into the denominator, 1 plus x, right, plus c, and there you have it. Okay, now does that work with the rest of these? Look at A, B, and C. You'll notice I don't have the parentheses, the power around them to be able to bring them all up. Okay, so if I don't have that power, okay, I mean, I guess I do, it's 1, right? But if I bring it up, this is where we're going to run into some trouble, because when we add 1 to -1, we get 0, then we have to divide by 0, world explodes. So let's go ahead and kind of investigate these, right? We're going to look at A. Now, on A, what I hope you would see is something that we've just been working with. I have 1 over 1 plus x squared dx, and I hope that you see that this is arctan type. that I have a 1 squared plus x squared. So this is just straightforward arctan of x plus c. And there you have it. Very, very simple. All right, let's look at b. On b, I have a 1 plus x. Okay. So I can't bring it up. This isn't arctan. I don't have the x squared. But I do have the natural log type, right? What's the derivative of the bottom? Oh, it's just 1. So I'm good, right? This is the integral of 1 over 1 plus x dx, which is the natural log of the absolute value of 1 plus x plus c. And there you have it. Very, very easy. Problem number C. Problem number C. This is also a natural log type. Okay, and I hope you see that in the denominator, I have a function of 1 plus x squared. So I do have to account for the derivative, right? And that hook is going to be 2x. Okay, so if I go ahead and just rewrite this, this is the integral of 1 over 1 plus x squared. I have to have a 2x as my hook. So, I mean, I have the x here, right? I have an x dx, but I also have to have a 2. So I'm going to drop in a 2, and I'll balance it with a 1/2. And then we get 1/2, okay, natural log of the absolute value of 1 plus x squared plus c. And there you have it. Okay, so those are my doppelganger. Let's go ahead. Let's ask the internet. Doppelganger. It's doppelganger. Okay, so those are my doppelganger problems. All right. Now let's go ahead and look at a couple more doppelgangers. Example 2, we were asked to integrate. I'm going to switch my pen here. Whoop. Okay. We want to go ahead and integrate some problems involving natural log. Whenever we have a natural log, you should immediately ask yourself, okay, do I have its derivative? Is there a u prime to account for this, which is 1 over x? And you'll notice in this problem I do, right? This is essentially a 1 over u problem, right? So I can go ahead and rewrite this as 1 over the natural log of x times 1 over x dx. Okay, so this is the natural log of the absolute value of the natural log of x. And I know that looks really, really weird, right? But it's right. Okay. All right, and then B is the more straightforward example of this. Again, here I can separate this. I have the integral of the natural log of x, and then the hook is 1 over x dx, right? I already have my hook there. Okay, so both of these, this goes away, and I can raise the power. This is natural log of x quantity squared divided by 2 plus c. And there you have it. Okay, so that is it. That's the doppelganger problems. They all look alike, but there's different types of integration and different nuances to approach them. Okay, catch you in the next video. Peace.